9.6, example 3. Now we're going to solve a nonlinear system by elimination. So I'm going to show you my notes here. I would again suggest that you copy these down so that you can refer back to them. But when we solve by elimination, our first step is we want both equations to be equal to y so that we can align the like terms. We want the y's and the equals to line up. If there are multiple x squareds, they line up, the x's line up, and the constants line up. Then we're going to eliminate the y's. The y's are always going to be both y equals, so we're going to eliminate the y's using subtraction because y minus y will get them to eliminate. And then we'll solve the resulting equation. Remember that your answer is always x and y together, so I can't stop here. I only found one variable. Then you take that answer, you plug it back in, and find the other variable. It is possible, again, to get no solution, one solution, or two solutions, so just be ready for that. We're going to do example 3. This is just from the textbook, and I just want to show my work. We can work through it together here. So here are the equations for example 3, and I want you to notice how I wrote the equations down. Here are the two equations the way that they gave it, y equals x squared minus 3x minus 2, and y equals negative 3x minus 8. But look at how I wrote it down, and I lined up the x's so that they're vertically aligned, and I lined up the constants so that they're vertically aligned. The second equation doesn't have an x squared term, so I just kind of left a blank here, leave an open space. Okay, I'm ready to do elimination. I am going to now subtract these two equations and get these y's to eliminate because y minus y will get them to cancel out. So on the left side, now I have 0 equals. The x squared I can't subtract with anything because there is no like term for it, so it's going to stay x squared. Don't forget we're subtracting, so negative 3x minus negative 3x, that's going to become plus 3x. These are also gonna eliminate, which is nice for us. And then let's subtract again. Don't forget we're subtracting. Negative 2 minus negative 8, that becomes plus 8. So this is going to become plus 6. Now this equation we're going to solve. It's a quadratic equation. Let's think about how we're going to solve it. Since there's no bx term, they cancel it out here, we're going to use square roots. Okay, let's isolate the x squared. So I'm going to subtract 6 from both sides. I would get negative 6 equals x squared. My next step would be to take the square root of both sides, but look at what happens over here. Remember, you cannot take the square root of a negative number. I cannot go any further, which means that this problem has no solution. No solution for this one. We can easily check our answer. Let's go to our graphing calculator and let's make sure that it matches up with the graph. So let's go to y equals. Let's type in the two equations, x squared minus 3x minus 2, and then negative 3x minus 8. Let's hit graph, and no solution means that they're never going to intersect, and look at what happens here. They're never going to intersect here, so no solution for this system. Okay, let's do some more like this. We're going to look at some monitoring progress questions. We're going to look at monitoring progress number 7. So I'm getting this from the textbook, and I'm just going to copy it down here. Monitoring progress 7. We have y equals x squared plus x. And remember what I said, when I write down the equations, I'm going to line up the like terms. So y equals, there is no x squared term in the second one. There is an x, and then plus 5 has nothing to line up with because there's no constant in the first one. So you don't have to do this, but I do find that it's easier if you line up the like terms vertically so that they're stacked on top of each other. Okay, we're ready to do elimination. We're going to subtract these two equations and eliminate these y's. I get 0 equals, here I have x squared Let's keep subtracting. Remember, we're subtracting here. X minus X, these are gonna eliminate as well. Don't forget, we're subtracting here. So this is really like a 0 is a placeholder up here. 0 minus 5 would be -5 or -5. So just be careful with that. Now this, again, is very similar to that last problem that we did, and there's no bx term, so I'm gonna use square roots again. Let's isolate the x squared. We're gonna add 5 to both sides. We get 5 equals x squared. And this one I can solve because I ended up getting a positive. So let's take the square root of both sides, and I get x equals, don't forget the square root of 5 is positive and negative. It's gonna be a decimal, so let's use our calculator. Square root of 5 is 2.236. Why don't we round to the hundredths place? So we'll do 2.24. We're gonna round to the hundredths place here, 2.24. Now just be careful. Remember that this is positive 2.24 and negative 2.24. So this one is gonna have 2 solutions for this. Okay, I found the x's, but I'm not done. I need to find the y's. So I need to take each x, plug it into one of the equations, and find the y's. Okay, let's do one at a time. We're gonna plug in positive 2.24 first. And it doesn't matter which equation you pick, but I'm gonna pick the linear equation because I think it's easier to plug it in than the quadratic. Let's plug it into here. If you wanted to do the quadratic, you could. Actually, that might be a nice idea for here, because if we left it as the square root of 5, it would actually end up coming out here, but we would still have to plug in our x over here. So it doesn't matter. Let's just do the linear equation. So we'll have y equals 2.24 plus 5, and there we have our first y. It's going to be 7.24. Let's write it as an ordered pair. So our x is 2.24 and our y is 7.24. There's our first answer. Let's do the second one where x is negative 2.24. We're going to plug it in to, again, our linear equation. Y equals negative 2.24 plus 5. I'm going to use my calculator just to make sure I do this right. Negative 2.24 plus 5 is 2.76. Okay, let's write that as an ordered pair. My x is negative 2.24 and my y is 2.76. And there I got my 2 answers here. Okay, again, I can check it by using my graphing calculator if I wanted to. And I do think it is worth your while to take the time to check. So let's do a quick check here and let's make sure that we got this correct. So our first equation is x squared plus x. Second equation is x plus 5. Let's hit graph. And we can definitely see it's crossing at 2 places here, and these are approximately the points that I just found. This one looks approximately 2.24, 7.24, and this one looks approximately negative 2.4, 2.76. So if you're satisfied with just the look at the graph, that's fine. If you want to, you can also do second calc intersect and get both of these points here. Let's do another example. We're gonna do one more. Let's look at monitoring progress number 8. So again, I'm getting this from the textbook here. Let me write down the 2 equations. Y equals 9x squared plus 8x minus 6. And when you write down the second equation, 5x minus 4, line it up so that they're aligned. 5x minus 4. Line up the x's, line up the constants. Okay, we're solving by elimination. Let's go ahead and subtract these 2 equations and eliminate the y's. On the left side, we have 0 equals. There's nothing going on with this 9x squared. It's going to stay the same. Don't forget we're subtracting. 8x minus 5x is positive 3x. And again, we are subtracting, so this becomes plus 4. Negative 6 plus 4 is negative 2. Okay, so this is the quadratic equation that we're going to solve here. Let's think about the best way to solve this one. Because this is in standard form and it has a bx term and the a is not 1, I think the best way to go about doing this is the quadratic formula for sure. Let's use the quadratic formula. Let's solve. Okay, remember this number is our a, b, and c. We're going to plug it in the quadratic formula. So here we go. We got x equals the opposite of b, so negative 3, plus or minus the square root of b squared, so 3 squared, minus 4 times our a, which is 9, times our c, which is negative 2, and this is all over 2 times 9. Okay, let's get our number underneath the radical. Negative 3 plus or minus the square root. Let's put this whole thing into our calculator here just to save some time. So 3 squared I know is 9. And then this is a negative 4 minus 4 times 9 times negative 2. And I get 81, which is nice. That's going to come out nice here. On the denominator, 2 times 9 is 18. Okay, don't forget that this plus or minus is going to split it up and to get our two x's here. So our first x was negative 3 plus the square root of 81, which is 9 over 18. Let's simplify. This would be 6 over 18, which reduces to 1 over 3. There's our first x. Let's find our second x. So it would be negative 3 minus the square root of 81, which is 9 over 18. This becomes negative 12 over 18. And let's reduce it here to reduce both by 6. So negative 2 over 3. There's our second x. Okay, we found our two x's. Now we need to find the y's. Don't forget, you can't stop here. The answers are ordered pairs, x and y. Let's take each of the x's, we'll plug them in, we'll find the y's. I'm gonna plug them into this linear equation here. Let's start with 1/3. If I plug in 1/3, we're gonna get y equals 5 times 1/3 minus 4. And I can just use my calculator to do this, or you could do it in your head. That's totally up to you. Let's use our calculator. 5 times 1/3 minus 4. And instead of leaving it as a decimal, let's use our calculator to change it back to a fraction. So we're going to do math, and then fraction is the first one. Enter, enter, and we get negative 7 over 3. Let's write it as an ordered pair. So my x is 1/3 and my y is negative 7 over 3. That's our first answer. Let's do the second one. We're going to plug in x equals negative 2 over 3. So it's going to be y equals 5 times negative 2 over 3 minus 4. Let's plug it into our calculator and let's find out what this equals. 5 times negative 2 over 3 minus 4. And again, I want to change this back to a fraction. So again, I'm going to hit math underneath the alpha key here. Math, enter, enter. And I get negative 22 over 3. Let's write this as an ordered pair. So my x is negative 2 over 3 and my y is negative 22 over 3. And that is our second answer, just like that. So we have two solutions for this one. Yes, it got a little messy because they were fractions, but that's okay. We should be able to handle them.